and 92.83. So this was our data set, and now we have it sorted. So I'm going to share again. We have it sorted in HDL. Oh, okay, clear. Thank you. Okay, perfect. Okay, so here it is. So this is in my second, I have it in my second column in the data set. It's all sorted. I know we have 54. Now I'm going to stop sharing. And let's discuss, we may not want to discuss all three. I'm just going to discuss at least the first one, and then you tell me if you need another one. So this is our bell-shaped distribution. Here is X bar. I think if I remember correctly, X bar was 79. Correct me if I'm wrong. I can look at it back there. Was it 79?
I believe so.
Okay. So now we want to identify this 68% and see if it is indeed between 45.6 and 69.22. It may not be 100%, but it should be there. So how do I determine this? So also, what is the percentage under the entire curve? How much? Everything.
100.
Thank you very much. Of course, 100%. So if this is 68, then this piece must be 34, and of course 34%. And can anyone give us the percent of this piece? Of course, under the curve. So from 50%, because this is 50%, and this is 34, how much should be this? Is it 16? Very good. So now we are going to multiply 54 observations multiplied by 0.16, and let's see what we get. 54 total observations multiplied by 0.16. I got 8.64. So roughly the 9th observation, or I can consider the 8th observation, is where I have to start counting. Also here, this piece has 16%, but from 100, when I subtract 16, I get 84, right? So this should be at 84%. So then 54 multiplied by 84%, 54 multiplied by 0.84, I get 45.36. So between the 8th observation and the 45th observation, so between 8th and 45th observation, I should have all of them between the 8th and the 45th observation. They should all be between 45.6 and 69.22. Since it's easier to count the first 8, and then it's easier to count 54 minus 45, which is 9, I will count backwards. So I'm going to share, and you'll understand. If I need to do another one, I'll do another one. So let me share again. So from the sorted data, I see the 9th observation, or 8th or 9th, they're both 44. So they're slightly outside of 45.6. So I'm going to write 44. And now I count from the bottom up. Or if you want, since we have the numbers here, this is the 45th observation. That's even easier because we have them counted. So 69. So now I'm going to stop sharing. So I determined, or I checked that between these two, which means the middle 68% of the data, is between 44 and 69. So what we got from the empirical rule was between 45.6 and 69.22. So it's a very good approximation. So you also noticed the data was not 100%, so I didn't expect to get 100%, but it was not 100% symmetric, so this was 68%. How did I do that? I determined this percent, I multiplied by the total number of entries, and I got the 8th or the 9th observation, roughly. 8th or 9th observation. How did I get this point? Well, if this is 16, then this must be 84. So from left to right. Or you can just count 16, and that's good enough, and you know, it's 9 from above and none from below. So you don't really need to determine the second one. You know that this has to be 9 and this has to be 9. Same thing. So this example was just checking. We were just trying to check to see if 68% of the data are roughly, very close though, between x bar minus 1 standard deviation, x bar plus 1 standard. I just did the first one. Any questions? Any questions? Is this okay? Okay, final here that I didn't get the chance to show you last time is about what it's called Chebyshev's inequality. So he said, and he proved, that for any distribution, we don't care whether it's symmetric or not. So this is quite powerful. This one was limited, right? The empirical rule is limited to bell-shaped data. If this data is not bell-shaped, these percentages do not apply. So this is a much more powerful result. This says, don't even bother to look at your histogram. Who cares? You will still, this is still guaranteed. Okay, let's see what he said. And what this means. So in this case, we don't care. We don't need to check the distribution. So he said that at least 1 minus 1 over k squared multiplied by 100% of the observations will be in the interval mu minus k, and I'm going to explain what k is. So k is a number greater than 1. It cannot be 1 because this will be 0. So k sigma, mu plus k sigma, for any data set. So if we choose k, and I said I chose k equals 2. Let's see what happens. I did not perform the calculations myself. So if, let's say, if k is 2, then, because we haven't calculated for k equals 2, we calculated for k equals 1 already, mu minus sigma and mu plus sigma. Well, this is what I just showed here. So now we know that for k equals 2, it will definitely work because the data is bell-shaped. So we know that that's going to be the case. But let's see what percentage we get. We don't have to calculate anything. We just have to show to see what percentage we get. So when k is 2, then we have mu minus 2 sigma and mu plus 2 sigma. And we know that our data set is bell-shaped, so the percentage should be 95%. According to the empirical rule. So I'm going to plug in k, which is 2, in here. So I have 1 minus 1 over 4. And this is 3 over 4. So 4 minus 1, 3 over 4. And this is 75%. Okay? So we know that it's even more than that. because the formula, the inequality says at least these number of observations will be between these two. And it's even more than that. It's 95. Okay, so this is basically the end of the last lecture. Now I would like us to go through this quickly and enter our, unless you already did, I did not check. So we want to compare these two histograms and find the mean and the standard deviation, and which data set has more dispersion. So what is this data that I got for you? It's from one of the slides. So they're asking us which of these two lines or queues we want to be in. We want to wait for our food at Wendy's or McDonald's. So we have the wait time. I have a little typo here, so this is 3.08. So I have a space between 0 and 8, so please make sure that that is clear. So this one is basically 3.08. So I did enter the data. And let me share again. I created the data set. So let me save this, although I didn't do much with it. Yes, I want to save. And now I'm going to get to the other data set that I just created this morning. Why does it take so long to save? Nothing. I may be logged out. I hope not. Okay, never mind. I'm not going to wait for you. I'm probably logged out. Oh no, okay. So I created the data set. I said Wendy's versus McDonald's. And now, first of all, let's create two histograms side by side. So go to histograph, the histogram. I'm just curious to see if it will allow us to present them side by side. Let's see. Ah, nice. We want the frequency. Okay. Now let's see what happens. I want to label the x-axis. How should I label it? Wendy's versus McDonald's. And the y-axis, I want to label it as frequency. And let's see what happens. Let's see if I want anything else. Dividers, none. Value. Okay, let's see what happens. Start at, no. Okay, I let StatCrunch do its thing. So, click on compute. Okay, so that's what it does. I really don't want this because I cannot see them at the same time, so this is fine. But I want to do separate then. I'd rather do separate. Okay. So now I go to this one and go to the second. So now I can compare them. I thought it would give me a big enough window. Maybe it does, but I don't want to waste your time. So, so let's talk a little bit about the two data sets, and then we'll determine the rest. So what will you say? Which of these two has more, has a higher dispersion, more spread? So which one you would say, I really would like to wait in this line versus that line? Would you prefer Wendy's, where the bulk of the wait time is between 0 and 2 minutes? Or you would like to wait at McDonald's, where, yes, a big portion is between 0 and 1 minute, but you have higher chances of waiting 4 minutes. So frequency 4 over there, frequency 5 over here, and frequency 4, and here in 16. So which line would you prefer to weight?
Wendy's.
Yes, absolutely.
Wendy's has better food.
Okay, thank you. However, for the purpose of discussing a dispersion, very nice, this is a much better, because the chances are much higher to wait between 0 and 2 minutes versus 0 and 4. So less spread, although, as you see, 0 to 4, the range, 0 to 4, here the 0 to 5, right? So chances are that you will wait in line more at McDonald's. Okay, so now let's create our summary stats by column. So we use McDonald's, and let's see what we can come up with. Let's see what we know already. We know, use the shift key to select whatever you want. The sample size, the mean, the variance, the standard deviation. We do not know what the standard error is yet. Median, we want the range. We want the minimum, we want the maximum. We don't know anything else yet. We will by the end of the day today. And let's say we select also the mode. Oh, I didn't mean that. Yeah, it's gonna do that again to me. Never mind, so I guess I'm not gonna select the mode. Sorry. So I'm gonna select the min. Up. Well, I hope you can do this. I'm having trouble. Minimum, maximum. I'm not sure why I'm having trouble with my key here. Okay. Mean, variance, standard deviation. I'm not sure how to do this. It didn't give me trouble last time.
It says select more than one with shift click or control click. So
Yes, I don't. This is what I just did, but it selects everything. I'm going to select everything. Anyway, I'm having difficulties with my software here. Okay, that's all I could select. I'm hoping that you were able to select more. I can't even see now with my equipment in the way, and anyway, that's all I wanted to show. So do the same thing and just enter your numbers. Not sure why I'm